So here's the question for this whole unit, the big question. And I went back and I looked at your what do you knows from when we started all this, and things like what do you think evolution is? And I think you guys have a different sense of that than you did. And, how does evolution happen? And I think you have a different sense of that than you did. But the question I've got and this was a good one when I looked at these. There were a few people who said things like, when an organism changes, does evolution happen in a single organism? No, of course not, Moser. Don't be ridiculous. It happens at the population level. Populations change. The question that I have for you now is this. When does evolution happen? Is it happening right now? Because this was a question some people had. Do all species evolve all the time? Do all populations evolve all the time? What do you think? Do you think that all species and all populations of all species are constantly evolving? Well, you might suspect that's the question we're going to answer. And I'd like to introduce you to a friend of mine. But there's my friend. You know what it is? It's not a trilobite. It looks a lot like a trilobite, though. Do you know what this is? They look terrifying. Who's seen these things before? I'm going to shrink that picture. You've seen these things before. Okay. Let's get some other pictures of them. Here's their underbelly. It's not a stingray, but a lot of people say that too. Horseshoe crab! It's a horseshoe crab. And they're actually not really related to crabs at all. Well, they are, but we're related to crabs too. They're more closely related to spiders than they are to crabs evolutionarily. And here is a horseshoe crab sex party. That's one female. Oh yeah, totally. One female under all that pile up, and a bunch of males hang onto her shell. She drags her body up the beach, burying her eggs, and as she drags herself, squirting out her eggs, the males just shoot sperm everywhere they can. Who gets to fertilize the eggs? We don't know. Those eggs remain buried in the sand. They eventually hatch. The faces that you guys make are so fantastic. I love every single one of you's going, it's great. And sometimes you'll have, I didn't hear that and I don't want to. Sometimes you'll have like 5 or 6 males who will all cling on to other shells, and they don't care who they're clinging on to because they're just going to jet sperm all over whatever comes out in front of them and hope that they fertilize something. Because they've basically got about 2.5 weeks to get this done. That's it for the whole year. And the hope is that they make 1,000 babies or more. Yeah. Now, a lot of those babies will die, obviously, because we know natural selection says more babies are born than survive. So she's going to shoot out probably, 1,000, tens of thousands. I don't know how many eggs. We'd have to look it up. And they're going to jet sperm all over them. And hopefully enough eggs will get fertilized that we have a big crop of baby horseshoe crabs. Why am I talking about horseshoe? I think these are cool. Do you know where these exist? What the heck? Let's just talk about stuff Moser thinks is cool. Because I can do that, right? Yes. I'm going to change the name of the course. It's no longer biology. It's stuff Moser thinks is cool. We're going to have a lot of fun. Okay. So I like horseshoe crabs because we go camping every year down on the Atlantic Ocean. It is the shortest, it's the closest Atlantic Ocean that you can get to. Should I tell you my secret? 6 hours. No, it's actually closer than that. 6 hours and 25 minutes if you do not stop to pee or get gas. So it takes us 7 because we have to do both. And that is Delaware, the northern tip of Delaware, the Delaware Bay. And there's a state park down there we camp at every year. It's the cheapest, closest beach you can get to. I think these things are important. You get a map and a circle and you draw little circles and where is the shortest distance to the cheapest beach I can go to? This is it. And as it turns out, and I didn't know this when we started camping there, is also the hot spot for my friends. So if you go down to the Delaware Bay and to the coasts of Delaware and New Jersey in June, it is a sex party on the beach. And this is not spring break with college students. This is horseshoe crabs doing it everywhere. everywhere. If you wade out into the Delaware Bay in the first few weeks of June, you'll be standing there innocently enough when you'll feel, I know, it's creepy, isn't it? And it's not on your, it's on your foot. They'll walk right over your foot. And they're really clumsy and they're really awkward. And I mean, seriously, could even their mother say they're adorable? Like, they're pretty hideous. They're pretty prehistoric looking. Like, who thinks they're attractive? Other horseshoe crabs. But you know, well, we're going to talk about how horseshoe crabs make this all work for them. Because they do. So every June, they go from, and they live actually in the lower ocean water. They live on the bottom of the ocean. And every spring, late spring, early summer, they head up to the coasts and they drag their clumsy, awkward, big-shelled bodies up onto the beach, and they partake in, well, this, lots of this for several weeks at a time. And they're awesome. They are so cool to watch. They are so cool. And you'll see on the Delaware Bay, you will see chains of like one huge female, because the females are typically larger than the males. You'll see one big giant female with like 5 or 6 little males hanging off of her. And they're just making more horseshoe crabs. Ooh, what are they doing? Making crabs. That's what they're doing. For a couple weeks in the spring. Now, why am I talking about horseshoe crabs? Okay, it's not really because I changed the course to things Moser thinks is cool, but I could. It's because horseshoe crabs have looked pretty much like this. How old do you think this species is? So let's look at our timeline up here. We got a timeline. We made a timeline of Earth history. So humans come in where? Like this line? You know, like a centimeter from the end. And dinosaurs go extinct here, and the first mammals happen here, and the first dinosaurs are here, and then the first plants are here, and the first fish are here. Trilobites are here. Complex fossils, worms back here. Atmosphere. How long? If you looked it up on Google, you're cheating. So I'm not calling on you. Cheater, cheater. How old do you think this species is?
Well, you said they're close to spiders.
They are more closely related to spiders. Would you believe me if I said about 400 million years old?
Yeah.
They predate the dinosaurs. These things have been on the earth and looking pretty much like they do longer than there have been dinosaurs, and we don't even have dinosaurs anymore. Before there were dinosaurs, there were these freaky looking things.
They look like them.
Having crazy sex parties on the beach. Right around the dinosaur's feet. Again, I didn't hear it, and I'm not going to ask you to repeat it. They were having crazy horseshoe crab orgies underneath the dinosaurs' noses. Wow. So why are we talking about this? Well, because the real question here is, when does evolution happen? Does it happen all the time? Do all species, do all populations evolve? And what I'm telling you is, because these guys are pretty much unchanged for the last almost 500 million years. How does a species make it that long? These are like the poster child for we don't have to evolve. So if we did, hey, do you remember this? This thing, what's it called? This is actually a slide. You have this slide. It's a, yes, this one happens to be a bell curve. It's a normal distribution. But overall, this is a distribution. Okay. Could we plot a distribution for any trait for any species? Yeah. I mean, we did it for what? Pinky length and wrist circumference and wingspan and height and length of foot and all this crazy stuff on people. We could do it for ear length on rabbits. Could we do it for tail spikes on horseshoe crabs? Sure. Could we do it for number of underbelly legs on horseshoe crabs? Sure. Could we do it for width of shell on horseshoe crabs? Sure. Could we do it for number of gills on horseshoe crabs? Could we do it for number of whatever the heck those little pointy things are there on horseshoe crabs? That's not the technical term, by the way. Could we do it for thickness of, that's called a carapace, their shell, thickness of carapace on horseshoe crabs? Yes.
You betcha.
You betcha. We could do a distribution for every single trait on these critters. And we've got fossil forms of these things. We could go back to the fossil record. And we could do distributions of all those characteristics on horseshoe crabs for the last nearly 500 million years. Ooh, that sounds like a fun project. Who wants to take a trip to Delaware to the beach and we'll capture horseshoe crabs and we'll, oh my gosh, I know what I'm doing next summer. And we'll count their little spiky things and we'll count all kinds of things and we'll measure stuff and we'll graph it. I so want to do this. Would you do this if it got you a trip to the beach?
Yes.
Me too. Me too. I'm just taking wild guesses, and this is just one of the many wonderful things that I'm going to count and graph next summer. But, you know, number of those weird spiky things on the horseshoe crabs. And just like with most things, we'd probably get a normal distribution. And, you know, if I go out to the beach and do this with horseshoe crabs next summer, well, and then I looked at fossil horseshoe crabs. As I said, these things have been nearly unchanged. So I'm going to say modern horseshoe crabs. What if I went and did this with fossil horseshoe crabs? What do you think I would find? You know what? It wouldn't be that much different. They haven't really evolved over the last almost 500 million years. Again, if it ain't broke, don't fix it. It's working for them. They're weird, they're ugly, they're totally harmless, and they're actually really sweet, and their belly is in between all those legs. So if you flip them over on their back and you put a little piece of clam there, they'll take all their legs and they'll push it into their belly. It's so weird. They're awesome. I know. You're thinking about what that would feel like. Like, boop, there goes my pizza. They're so cool. So their distribution of pretty much any trait you care to name hasn't changed. Well, what was our big question? Does evolution happen all the time? When does it happen? Where does it happen? Why does it happen? Are all populations evolving? We said horseshoe crabs really haven't evolved. Which means, well, wait, what is evolution? We said that all a distribution shows is that there's variation. It shows how a trait is spread out, and it shows what percentage of individuals have some trait. We could also do this. Do you remember this? So, whoops, let me flip that. 0%, 100% gene for, it's characteristic of horseshoe crabs, 2-layer carapace. Maybe some horseshoe crabs have a thinner carapace. It's only 1 layer of chitin. Maybe some have a thicker carapace. It's 3 layers of chitin. But if we look at the gene for that, remember, evolution is a change in distributions. It's a change in gene frequencies. That's all it is. Can those distributions change? We talked about bunny ears, shifting bunny ear distributions. Can distributions change? Yeah. What do we call it when distributions change? Evolution! Evolution! That's what we call it! Evolution! Sorry, that was probably unnecessary. Yeah, all evolution is the shifting of traits or gene frequencies in a population. And guess what? Horseshoe crabs have not been shifting. They have stayed the same for almost 500 million years, over 400 million years. Equal, the same. When distributions are not shifting, they are at equilibrium. When a population is at equilibrium, it is staying the same as it has been. And if this distribution remains stable, doesn't change over a whole bunch of generations, the whole population is at equilibrium. And guess what? Horseshoe crabs are the masters of equilibrium. They are rock stars of not changing anything. So, we say if the distribution remains the same over many generations, how many generations do you suppose 400 million years is? A lot. A lot. So we're going to actually watch a little bit of we're not going to watch the whole thing, but we're going to watch a few bits and pieces of a nature special, PBS Nature, on horseshoe crabs. Because I want you to think about what would put this population under pressure. So we talked about snakes in swamps last chapter. Remember that? Snakes in swamps? What was snakes in swamps? Pythons in the Everglades. Remember this? What happened when it got cold? A bunch of them died. Would you think that horseshoe crabs have gone through similar events? Seriously, 500 million years? Has the planet changed? Yeah. But somehow they just keep on ticking. So what we want to know is a little bit about how and why and how populations of a species can stay the same for that long. So we are going to watch a couple little clips, as I said, from PBS Nature's special on horseshoe crabs.